beam has the following dimensions: top flange 400 by 40 mm, wave size 100 by 200 mm. So live load it is given 4.5 kilonewton per meter. Then it is simply supported span 5 meter. Allowable stress in concrete 15 MPa in compression and 0 in tension. Question: find the pre-stressing force and eccentricity. Assume loss ratio it is 0.8. And also check for safety. Okay. So in this example, there are top stresses and bottom stresses it is given. Means in compression and tension stresses it is given. So we need to find out the pre-stressing force and eccentricity. Okay. So in analysis part, we are calculated top stresses and bottom stresses. But here it is given top stresses and bottom stresses. We need to find out the pre-stressing force and eccentricity. Okay. Just I will explain how we calculate the pre-stressing stress. So first, draw what is given. So first, draw the section of this. So T section it is given. Okay. So top flange it is given 40 by 40. Sorry, 400 by 40 mm. 400 by 40 mm. 400 by 40 mm. Then wave size it is given. Wave size it is given 100 by 200 mm. Okay. 100 by 200 mm. 100 by 200 mm. So these are the this that is top flange. Okay. This 200 it is wave size. Okay. This one it is wave size. Okay. So next, what is given? Stresses. Okay. Allowable stress in concrete it is given 15 MPa in compression. Okay. So for first stage, 15 MPa in compression. This one it is for stage 1. Okay. 0 at the top and 15 MPa at the bottom. Okay. Straight otherwise. So why it is triangular shape? Because in compression zone it is given 15 MPa and in tension zone it is given 0 M. Okay. So due to pre-stressing top at the tension, at the bottom it is in compression because hugging type of bend should be occur here. Okay. So this one it is for stage 1. This one it is for stage 1. Right one. This one it is for stage 1. Stage 1 means it is initial stage. So in initial stage we are considering only self weight of beam. Okay. And in stage 2 we call it is final stage. So in that top it is 15 MPa and bottom it is 0. Okay. 0. So this one it is for stage 2. For stage 2 means it is final stage, including external loading. Okay, means live load. Okay. So beam it is given simply supported beam. Beam it is given simply supported beam. Yes, simply supported beam. Simply supported beam. Simply supported beam. Span of beam it is 5 meter. Span of beam it is given 5 meter. So loading it on that beam it is uniformly distributed load. Due to self load it is uniformly distributed load. So live load it is also given UDL loading, uniformly distributed loading. Okay. So this part it is given in example. So first of all we find out the properties of this section. Properties of this section means we find out the Y bar. Okay, we find out the Y bar. This dimension it is 400. And this one it is 40 mm. Wave size it is 100 by 200. Okay. 100 by 200. Okay. Is it completed? So now we calculate the X bar, Y bar. Sorry. First of all, we calculate the Y bar 400. We need to find out the Y bar. Okay. Find out the Y bar. What is formula for Y bar? Y bar is equal to A1 Y1 A1 A1 Y1 plus A2 A2 Y2 divided by A1 plus A2 divided by A1 plus A2 A1 plus A2. Okay, so write down A1 means first of all we divided it is in two parts. So wave size we consider part 1, flange we consider part 2. Okay. So A1 it is 100 into 200 mm. Write down 100 into 200 mm. So Y1 it is measured from bottom side. Okay, from this side. So 200 divided by 2 it is 100 mm plus A2 it is flange size 400 into 40 mm into Y2 it is 200 plus this 40 divided by 2 means how much it is 220. Okay, 220 divided by A1 plus A2 divided by A1 plus A2. 100 into 200 plus 400 into 40. Tell me how much? Y bar one it is y bar from bottom sides. Okay. How much? Let's do the calculation. 100 into 200 into 100.
153.33.
553.33. Yes, correct. How much? 553. 100 into 200 into 100 plus 400 into 40 into 220 divided by 100 into 200 plus 400 into 40. 153.33. 153.33 mm. So this one it is what? Y bottom. Okay. So everyone got same answer. So now find out the moment of inertia. Find out the moment of inertia. Find out moment of inertia. Moment of inertia. Ig is equal to Ix plus AH square. Okay. Ix plus AH square. Okay. So there are two sections. So Ix1 plus Ix2. Write down. Apply the moment of inertia here. Otherwise, here we can write summation of Ix plus AH square. Okay. So first of all, Ix1. So this one it is part 1. BD cube by 12. 100 into 200 cube by 12. Just write down. 100 into 200 cube divided by 12. 200 cube divided by 12. 12. Then plus AH square. A1 means area of this first part. 100 into 200 into H square means y bar minus y1 square. So y bar we have calculated it is 153.33 minus y1 square it is 100 square. Okay. It is 100 square. 100 square. Square, then plus again for flange BD cube by 12, or BD cube by 12 means it is 400 into 40 cube by 12. 40 cube by 12. 40 cube by 12. Then plus it is 400 into 40 into H square means y bar minus y2 square. So y2 how much? It's 200 plus 40. 40 by 2. 200 plus 40 by 2 it is 220. 220 bracket. Okay. Tell me how much Ix
196.80 into 10 raised to 6.
Yes, correct. 196.80 into 10 raised to the power 6 mm raised to 4. Okay, mm raised to 4. This one it is moment of inertia. Okay, moment of inertia. So next, find out the cross-sectional area of this beam. Okay, everyone got same answer? You can cross-check this by I will upload this same video on our edFly. Okay. So now next, cross-sectional area of this beam. So first wave size it is 100 by 200 plus top flange it is 400 into 40. You get the total cross-sectional area of this beam. How much cross-sectional area of beam? 100 into 200 plus 40, 400 into 40. It will be 36 into 10 raised to the power 3 mm square. Okay, mm square. So this one it is cross-sectional area of beam. Okay, so why need find out this cross-sectional area of beam? We need finding for the self weight of beam. Okay, self weight of beam. Calculate self weight of beam. Self weight of beam. So how you calculate self weight of beam? So unit of concrete into cross-sectional area of this beam. Okay, so unit of concrete is, if it is not given, then we assume it is 25 kilonewton per meter cube. Okay, so unit is 25 kilonewton per meter cube, but our cross-sectional area it is mm square. So convert it is in meter square. How you can convert it is in meter square? So divided by 1000 square. Okay, why 1000 square? If you want to mm to meter, so we are dividing 1000, but here mm square. That's why divided by 1 divided by 1000 square. Okay, 1000 into 1000. It will be multiplied by 1 into 10 raised to the minus 6. 1 into 10 raised to the minus 6. Okay, so you get the self weight of this beam. Okay, so how much self weight of beam? So 25 it is a unit weight of concrete. Keep remember, 25 it is a unit weight of concrete. Okay, tell me self weight of beam how much? 25 into 36 into 10 raised to the power 3 into 1 into 10 raised to the power minus 6. So here the unit weight of concrete it is self weight of beam. Sorry, self weight of beam it is how much? 0.9 kilonewton meter per meter. Okay. Below write down bending moment due to self weight. Bending moment due to self weight. Self weight. So beam it is simply supported. Okay. Beam it is simply supported. What is bending moment formula for simply supported beam? When UDL loading it is 0.9 kilonewton per meter cube. So we denoted MD, bending moment due to self weight. It will be W, we call it L, W L square by 8. Okay, and the beam it is simply supported uniformly distributed load, then maximum bending moment it is WL square by 8. WL square by 8. Okay. So W it is WD, that is self weight. Okay. 0.9 into span, it is span of beam, it is simply supported span, it is 5 meters square. 5 meters square divided by 8. Divided by 8. Divided by 8. How much bending moment due to self weight?
2.81.
2.81, correct. 0.9 into 5 square divided by 8. It is 2.81. 2.81 kilonewton meter. Okay. So this one it is bending moment due to self weight. Okay. So next find out bending moment due to total load. Total load means including live load. Okay. Including live load. Okay. Bending moment due to total load. Write down. Bending moment due to total load. Total load. Okay. So total load on the span, it is total load on the span. First it is 4.5. Self weight it is 0.9. Then plus live load it is given in example. So it is 4.5 kilonewton per meter. 4.5 kilonewton per meter. So total load on the span it is 0.9 plus 4.5. So this one it is 5.4 kilonewton per meter. So this one it is total load on that span. Okay, total load on that span. So bending moment due to total load. Bending moment due to total load. Calculate MT is equal to W into L square. W into L square divided by 8. Divided by 8. Divided by 8 is equal to, so W it is 5.4 into span it is 5 square. 5 square. 5 square divided by 8. Divided by 8. Tell me how much bending moment due to self weight, due to total loading, self weight plus live load. 5.4 into 8 square divided by 8. 5.4 into 5 square divided by 8. Was 16.875 kilonewton meter. Okay, so we got same answer.
Yes, sir.
Okay. So now find distressing force and eccentricity. Find distressing force and eccentricity. Right now, find distressing force and eccentricity. Okay, so we need to find out the distressing force and eccentricity for stage 1. For stage 1, or in bracket you can write initial stage. initial stage. Okay, stage 1 or initial stage. Okay, for stage 1 or initial stage. Okay, so write down below for stage 1. For stage 1, we are considering only self weight of beam. Okay, only we are considering self weight of beam. We know the formula. First of all, calculate sigma top. Sigma t is equal to sigma t is equal to write down P by A, E by A, E by A. So this one it is due to pre-stressing force. That's why minus PE minus PE minus PE minus PE divided by ZT divided by ZT divided by ZT. So this one it is due to pre-stressing force. Then due to self weight, it is at the top, it is compression. So plus bending moment due to self weight. Okay, for initial stress, MD divided by ZT. Okay, so put here sigma t it is 0. For initial stage, we are considering it is where it is given for stage 1, top stresses it is 0. Okay, so 0 is equal to P it is unknown value, then divided by put cross-sectional area of beam, put all these values there. Put all these values here. All these values. Cross-sectional area of beam we are calculated. How much it is? 36 into 10 raised to 3. Correct? 36 into 10 raised to the power 3. Then minus PE, it is also unknown. PE divided by ZT, we need to find out the ZT here. Okay, how to calculate ZT value? Here I will calculate. ZT is equal to I by YT. Okay, I by YT. ZT is equal to I by YT. Moment of inertia, it is how much? Moment of inertia is 196.8 into the 10 raised to the power 6 mm raised to 4 divided by yt means center from the top of this section. Okay, so bottom section we are calculated. From bottom we are calculated how much we got. We got it is 153.33 from bottom side. Overall depth of this section it is 240 minus 153.33. It will be 86.67. Wide top it is 86.67. Tell me how much ZT is equal to. (196.8) into the standard power 6 divided by 86.67. It will be 2.270 into the 10 raised to the power 6. 10 raised to the power 6 mm cube. Okay, just put here this one value. Two point 270 into the 10 raised to the power 6 mm cube. MD, movement due to self-hit. How much movement due to self-hit we are calculated? It is movement due to self-hit it is 2.81. 2.81. It is kilonewton meter. Converted it is in Newton mm. 10 raised to the 6 divided by section modulus. 2.270 into the 10 raised to the power 6. Now we'll get one equation here in terms of P and PE. Write this equation in terms of P and PE. Write down this equation. My equation 0 is equal to 1 divided by 36 into 10 raised to the power 2.77 into 10 raised to the power -5. In terms of this one it is P. And next minus 1 divided by 2.270 into 10 raised to the power 6. We get it is 4.405 into 10 raised to the power 10 raised to the power minus 7 in terms of PE, then plus 2.81 into 10 raised to the power 6 divided by 2.270 into 10 raised to the power 6 till we get 1.23. 2.81 divided by 2.270, 1.23. Okay. So write down this one. It is equation number 1. So first stage 2 means it is final stage. So in final stage we are considering lie load as well as loss ratio. Okay. So we can write here. So N into P divided by A divided by A, then it is plus or minus at the bottom. Due to pre-stressing at the bottom, it is compression because hogging type of bend occurs due to pre-stressing force. So it will be plus again. It is N P into E divided by again this one, it is ZB the bottom. Okay, section modulus at the bottom, it is ZB, then minus. So we are considering here bending moment due to total load, that is MT, total load. Okay, bending moment due to total load MT, again divided by ZB, again divided by ZB. Okay, ZB. Okay, so write down. So sigma B, it is 0, is equal to loss ratio, it is given 0.8. N means that is loss ratio. So it is mentioned in example, that is 0.8. Okay, 0.8 into P divided by cross-sectional area. It is how much cross-sectional area? 36 into 10 raised to the power 3. Correct? Cross-sectional area 36 into 10 raised to the 3. Then plus 0.8 into P into E divided by ZB. ZB means I by YB. Okay. So how much is I by YB? Moment of inertia is 196.8 into 10 raised to the power 6 divided by YB, it is 153.50. It will be 1.283. 1.283 into the 10 raised to the power 6. Okay. Again, then minus bending moment due to total loading 16.87. Okay. 16.87. So this one, it is kilonewton meter, and what it is in Newton mm, 10 raised to the 6. Okay. Again divided by ZB. So this one, it is 1.283 into the 10 raised to the power 6. Okay. So write down one equation here. Write down 0 is equal to 0.8 divided by 36 into 10 raised to the power 6. In terms of P, it will be get 2.22 into the 10 raised to the 10 raised to the power 10 raised to the power minus 8 in terms of P, then plus 0.8 divided by 1.283 into the 10 raised to the power 6, 6.235 into the 10 raised to the power 10 raised to the power minus 7 in terms of P into E, then minus 16.87 divided by 1.23, 16.87 divided by 1.283 to be 13.14. 13.14. Okay. So this one, it is equation 1 and 2. To solve these quadratic equations, you will get the P. Solve this quadratic equation, you will get the P and PE values. So solve this on your calculator. How you can solve this one? Anybody know? Solve this quadratic equation, you will get the P and PE values. Tell me these P and PE values. Write down. You got P is equal to 3686 kilonewton, and you got the eccentricity E is equal to 595 mm. 595 mm. You don't got same answer.